So this is the fifth experiment implementing stack and queue using linked list. So this is the code I've used, and in the first line we are actually like creating a class node, which we will be using to do all the implementation. And here this is the constructor and self.data is equal to data. This defines the node where the data is going to be stored, and self.next is equal to none. This refers to the node next to the head node, and we are actually going to do linked list and class linked list defined in we are actually defining the head to be none. This is the key. Head node is the first node. Insert at the beginning. Here the data which we are going to enter is stored in the first node, and which will be turned into the head node. And define insert at end. This checks if there is no element in the linked list, and if there is no element in the linked list, this is same as like inserting at the beginning. And if it is not, there is element actually present in the linked list, this like uses the temp and skips to each element and inserts the element at the end, creates the node at the end. Define insert at position. This if the position is equal to 0, this is same as inserting the data at the beginning, like inserting data in the head node. And if it is not, it actually alters through every node and searches for the position and enters the node there. And delete by value. This searches for the value, and if the value is like equal to the value which is there in the linked list, it removes it and unlinks it from the linked list and doesn't print it. And if the value is not present in the linked list, it returns value not found. And delete by position. What this does is, if there is no element, it returns list is empty. If there is actually an element and it is present in the position, it it actually searches through every node in the linked list and deletes the deletes the element in the position and unlinks it. And if it is not the position is not in the range, it prints out position out of range. Define search. This searches through every element using the temp. If the value is equal to the node is equal to the value, it returns true, and if it is not, there is no value, it returns false. Display self. This displays every element, and if there is no head, there is like no element, it returns list is empty. And if there is element, it prints every element and like prints out none at the end so that we know it is completed. And now we are implementing stack using linked list, and we are creating a class named stack, and self.top is equal to none. We are actually declaring the top element to be none, which is empty. Define push. This pushes the new element to the top, like this node. This is the head node. It pushes the new element to the head node, which becomes the new node. Self.top is equal to new node. Top becomes a new node. And define pop. If like there is no element at the top, if not self.top, there is no element at the top, it prints stack underflow. Stack underflow happens when there is no element in the stack and we are trying to like pop something out, remove something out. And if it is not happening, like if there is nothing at the top, it prints out stack underflow. If there is an element, it prints out print popped and the element that is popped. Define peak. If there is actually elements, it prints out the top element. And if there is no element at the top, it returns stack is empty. If the stack is empty, it cannot return the peak top element. And define display dot self. This displays the elements. And if the top there is no element at the top, it returns stack is empty. And if there is elements, it like prints out each stack content top to bottom. It prints every element from the top to bottom of the stack, and that's it. It like prints with the arrow mark, and it ends the print with the none so that we can know if it is completed. And queue using here we are implementing queue using the linked list and class queue. Define it like we are declaring the front and rear to be null. If it is like an empty linked list, the both of them should be like none. And define enqueue. Enqueue is where you add an element to the like rear of the linked list. So new node is equal to creating a new node. If not, self dot rear. Like if the element is empty, like the queue is empty, like self front and rear, everything should be like a new node. And self dot rear is equal to new node and self is equal to new node. Okay. Here, if it is not an empty queue, the element is enqueued, like added to at the rear, and define dequeue if okay, if self not like not front, this means that if there is like no element in the front, it prints out queue underflow. There is like no element to be removed from the front, and if there is actually element, it dequeues the element from the front and define display. This displays like if there is elements, like if there is an element at the front, it prints out queue is empty. There is no element in the front, it prints out queue is empty. And if there is elements, it prints out each and every element. While temp is equal to, it prints with the arrow mark and returns none at last, so that we know the queue is completed. So this is the main menu, the L1 for linked list and Q1, ST for stack and Q for queue. While true, it like prints out all this. Like this is the first menu driven, and here it asks us for the main menu list like if you have to do linked list operations or stack operations or queue operations, and we have to enter our choice. And if we enter any of those, it goes to this, and here we can choose from what we have, what we want to do. And if this is like basic if else statement, if the C is 1, like we have to insert at the beginning, it uses the insert at the beginning function and all that. And if this is for the stack, we can push pop peak display and we can go back to menu. And this is for the queue, and we can enqueue, dequeue, display, and back to menu. If we enter the option 4, it exits the program. Else, if we enter anything else from these options, it prints invalid choice again. So now, if we run this code, so now if we run this code, it gives us the options. We have to perform linked list operations. So it gives us all these options. If we want to insert at the beginning, we give option 1, we enter the value, and we can enter a few more values. So we have entered a few values. So if you want to insert at the beginning is done, and insert at the end. If you want to insert at the end, we give this option, and we give 3. So it is inserted at the end. And if we have to insert by at the position, first let's display all the values you have entered, and it is all entered 756 43, and 3 which are entered at the inserted at the end is here. And if you want to insert at the certain position, we give this, and we have to give a value, let's for example 5, and enter the position which we have entered. Let's keep it like 0 and 1, we have to enter it here. So I'm giving 1, and it is inserted. As you can see, 5, the 5 is inserted at the first position. So now for the deletion, if you want to delete by value, give the option 4, and if you want to create like delete 5, we give 5, and it is deleted. And if we display, the 5 is removed here. And if you want to delete by the position, we give option 5. And let's take for an example, let's remove this 45. The position of 45 is 2, and we give 2. And now if we display it, like the 45 is gone. And if you want to search something in the linked list, we give this. And for the value is like, let's give 56, and it is present found at the position 1, and that is all about linked list operations. Let's skip to the next operations. Now stack. If like there's this basic functions in stack, push, pop, and peek. If we want to push something, let's give 1, and this push, and let's push a few more values. Now we have entered 3 values, and if we want to like peek, look at the top value, let's give 3, and top element 67. The 67 is the last element we have entered. And if you want to pop something, let's give 2, and if it is popped, the 67 is popped, like that's the top element, and it is popped. And now if we click display, the top element is 67 is removed. There's like only 43 and 65 here, and that is all about queue, I mean stack. Now for the queue operations, If you want to enqueue something, let's enqueue a few values. Let's enqueue a few values, and so now we can display it. And there is like 23, 56, and 7 here. And if you want to dequeue something, let's give 2. It is dequeued. The 23, the first element, like the enqueue takes place from the backside to front side, rear to front, and the dequeue happens from the front. So if we all this is done, and if we display, there's like 56 and 7 here. The DQ is done from the front and 23 is removed. No, there's like 56 and 7 left. And that is all about this experiment. Let's see.